Okay, 3.1, describe transformations of exponential functions and solve exponential functions. That's what we're going to be doing. Okay. Hopefully you'll have a little bit of information from last year. Come on, you can do it. I believe in you. Okay, so an exponential function with base a is f of x equals a to the x. An exponential function is where the variable is in the exponent. What?
These.
So the variable is in the exponent. A is a number. That's why I said a is greater than 0 and a is not equal to 1. 1 is not an exponential function because 1 to the 8th is what? 1. Okay, so 1 is not an exponential function. The base of 1, it just gives you 1 and it doesn't go anywhere. We're all good. So what makes it an exponential function? Just because it has an exponent, or what's special about the exponent?
It's any real number.
Not the exponent. It's a what? It is any real number, but it is a what? What is x? A variable?
Yes.
Yes. Okay, so that's what makes it an exponential function, is if the exponent is a variable. Okay?
Is this where it's like a to the x minus 4 or something?
They do different things. Okay, am I good?
Yeah.
Okay, so we have evaluated a to the x for integers and rational values of x. So 4 to the third is 64. 4 to the 1/2 is 2, because what does 1/2 mean? No.
By 2.
No.
Square root.
Square root, because there's a 2 there and a 1 there, and you get 1/2. So what if I had the cube root of 2 squared? It'd be 2 to the 2/3. Okay. So if you need to interpret forms of irrational exponents as well, to do it, use the calculator. Obviously, I can take 4 to the 6th, and it might take me a minute, but taking 4 to the 3.1 or 2 to the 3.1 is more difficult, yes? Okay, so in your calculator, you all know where the caret button is, yes? Okay, so if I have 2 to the x and x equals negative 3.1, I would just put 2 caret negative 3.1 in my calculator. And please come in before class.
You're late, Brianna.
I'm recording.
Everything's going slow.
Okay, so what did you guys get?
0.12.
Point.
8.57. Did you put negative?
I got 2 to the point 3.1. I got I got equal to 0.11663 is what my calculator gave me. So,
I got that too. I just tried to put it negative.
okay. What does a negative exponent do? Just to remind ourselves.
Makes it smaller.
Well, it does make it smaller, but it actually puts it in the denominator. Or if it's in the denominator, you move it to the numerator, and then the negative is gone. Okay, so do 2 to the negative x, and x is pi. So 2 to the negative pi. And you got to find the pi button in your calculator.
Oh, I see it. Where? It's right. It's blue carrot. I have a yellow carrot. Mine's blue.
Mine's blue also.
I'm
So I get 0.11331. Is that what you guys get?
Yeah.
Yeah.
Okay. So we can use our calculator when they're irrational forms, and that's when we'll use them, but you won't use them much. Not in here, at least. Okay, use the same coordinate plane to graph the following functions in your calculator. So in your calculator, go to y equals, and I want you to put 2 to the x, 4 to the x, 8 to the x, 15 to the x in your calculator. So that would,
Different ones.
yes, on different ones.
Where do you think you're going?
He's getting a
Your mom's house?
Any calculator.
calculator.
Then later, I'll put that.
Oh.
So,
Yes, babe, why are you putting our test? I don't remember what you did. Yes, ma'am.
What?
Why did you put in our test?
Because I forgot the answer key here. And I made one Friday, and then I just didn't grade them.
Keep it that way.
I would change the sign, the equal sign on the y equals on the calculator because it's on less than.
Oh, I changed it. I was doing something. Go back, like highlight it, and hit enter till it says equal.
I don't want to highlight it.
Go back with your back arrow. Or just go to Y2.
Okay.
So 2, 4, 8, 15. I'm going to bring up my calculator. And so this is going to go away. Two, 4, 8,
16.
16,
15.
15.
Sorry. You were right. How dare you? I forgot what time it was.
Okay, what do you notice about them?
They are different.
Well, how are they different? And it's harder to see when you have the older calculator because you can't see it in different colors. If I graph, there's 2, 4, I got 2 reds. 2, 4, 8, and 15. What happened to it as the base gets greater?
It got smaller.
It got smaller. What do you mean smaller?
It got more narrow.
It got more. It got narrower. It
Yeah.
increases quicker. Yes. Why would it increase quicker?
Because it's bigger.
Because it's bigger. It's a bigger number you're squaring or cubing. So it does get narrower in reference to the y-axis, yes? Okay. So that's what I wanted you to see there.
Right.
Okay, so this is the stuff you need to know about the exponential function. It looks like this. This is the parent function, so it's y equals a to the x. You should be writing all this down. So y equals a to the x. A has to be bigger than 1 because 1 is not an exponential function. The domain is all real numbers. The range is 0 to infinity, and 0 is not included. Is there any exponent that would give you 0 for an answer? No. It may give you a number really, really close to a 0, but it does not. The y-intercept is 0, 1. Now, what is the reason for that? What is any base to the 0 power? What does it equal?
What did you just ask?
Any number to a 0 power, what does it equal? 1. So is that why the y-intercept is 0, 1? Yes. Now, unless we move it left or right, up or down, is it always going to be 0, 1? Yes.
Oh, is this the parent function?
Yes, this is the parent function. It is increasing. The x-axis is the horizontal asymptote. And I don't know why it's have increasing and then continually increasing, because I think the continually increasing takes care of the increasing. What do you think?
I'm good.
I'm not.
This is also known as a growth function. Why?
Because it's growing.
It's growing. It's increasing, yes? So exponential functions are used in lots of things. Chemistry, a lot. But they're usually not growth. In chemistry, they're decay. Well, I guess I shouldn't say that, but I hear decay more. Is everyone good? All of you good?
Yep.
Okay. Okay, so what did I change between the function I just had to this one?
Is that negative?
It's a negative. So remember, a negative reciprocates it. So it's actually 1 over a to the x. So this is a decay function, and it's not increasing. It is what?
Oh, what was the other one?
The other one was the growth function. The parent was a growth function. Mm-hmm. So domain is still all real numbers. Range is still 0 to infinity. Y-intercept is still 0, 1. The horizontal asymptote is still the x-axis, but what's the only difference?
It's decreasing.
It's decreasing from left to right, correct? So when we have like vertex form, when we have plus or minus a f of x plus k, actually I shouldn't write it like that. When I have this x minus h plus k and some, k is 5 evidently. This is some function. I don't know what function it is. What happens if I put a negative on the x? What's it reflect over? The y-axis, correct?
Mm-hmm.
Okay, so did we put a negative on the x? Okay, is that why it's reflecting over the y-axis? Yes. So growth, the only difference between growth and decay is one is increasing and one is decreasing. Is everything else the same? And we will have this vertex form will be y equals plus or minus a plus or minus x minus h plus k. But we won't be moving the vertex, we will be moving the y-intercept. Because the y-intercept is the one point that's common for everything. So h still moves it left or right, the opposite direction. K still moves it up or down. This reflects it over the x-axis. And this reflects it over the y-axis. So I didn't lie to you last year when I said every single graph from here on out, that's what I would be teaching you. So that's what we're doing. I probably skipped a slide because it's probably on the next slide.
What?
That information I just wrote is probably on the next slide. Tell me when you're good, Alex.
On tomorrow we have a worksheet? Or no worksheet? Yep. Cool. Shut up.
Alex, you good yet?
Yeah.
Not me. Still.
Okay, so what is happening? I have 3 to the x, and I have negative 3 to the x. What's happening with this?
Yeah.
What's that negative do? Reflects over the what?
X-axis.
The x-axis. So 3 to the x looks like this. correct? Or something like that. So if I reflect this over the x-axis, it's not going to go through 0, 1. It's going to go through 0,
Negative 1.
-1. And it's not going to be above the x-axis. It's going to be below. So my domain is still all real numbers, but my range is 0 to negative infinity. Actually, I wrote that wrong. What's supposed to come first?
Negative.
Yeah.
Negative infinity. Okay, so this is negative 3 to the x. Okay. So what about the next one? It reflects over the y. So the original is like this. 3 to the x. And so 3 to the negative x. Actually, on the first one, it's increasing. On the second one, it's decreasing. Like increasing, decreasing, right? And when you go to the second example, 3 to the x is increasing, and 3 to the negative x is also decreasing. So what happens if I have a negative here and here? It reflects over both. So
it's going like that to the negative 1.
so it started here and then went here and then would end up like that. Yes? Because if you reflect this over that, that is horrible. So in this case, remember with parabolas, we didn't really reflect over the y-axis because you could just move it left or right and take care of it. But here, do all those reflections change what happens? Yes. Alex, let me know when you're good. That's what that one would be, right? Ours were much better. Okay, switch. Okay. Since the graph passes the horizontal line test, we know that the function is 1-to-1, so we can use the 1-to-1 property. The 1-to-1 property is like the best thing in the world. I always call it like the duh property. Again, x has to be greater than 0 and a has to be greater than 0 and a can't be 1. If you have a to the x equals a to the y, then doesn't x have to equal y? Mm-hmm. So the 1-to-1 property says if a to the x equals a to the y, then x equals y. That is the 1-to-1 property. So if the bases are equal, guess what? The exponents are equal. Well, this if and only if also says if the exponents are equal, then what are equal? The bases. So that's one of those, sometimes you'll get one of those on the ACT that they won't give you same bases, they'll give you same exponents. So it's just nice to know. Good? Okay, so 9 equals 3 to the x plus 1. So you have to get same bases. So can I write 9 in terms of base 3? It's 3 to the what? Second. So you would write 3 to the second equals 3 to the x plus 1. So the bases are equal, so we know what are also equal. The exponents. So we know that 2 equals x plus 1. And so x equals what? 1. Now that's a pretty basic one. We can get a quadratic up in the exponent. We could get lots of things up there in the exponent, okay? So the next one, I have 1/2 to the x equals 8. So what base do you think we want?
Enough.
2.
2. Okay, so 8 is 2 to the what? Third. So I have 2 to the third. But I need to get this 2 out of the denominator and bring it up to the numerator. So what do I do to the exponent? Make it negative. So on the left, it's 2 to the negative x. So now that I have bases equal, what do I know about my exponents? They're equal. So negative x equals 3. So x equals negative 3. You guys remember them now?
Yeah.
Okay, so you just got to get those same bases, whatever they may be. You good, Alex? Okay, so try these two on your own. Okay, did it go okay? Okay. Just remembering to reciprocate that. Could I have made it 1/3 to the x equals 1/3 to the fourth, to the negative fourth? Yeah. I've had a few students throughout the years that see it that way. Most do not. I typically do not. But they do it that way. So if any of you see it that way, go for it. Why did it go backwards? Oh, okay. It didn't go backwards. I just wasn't paying attention. Okay, so we have 3 to the x. Yes? So goes through 1. If you want to know, like if you put in 2, you get 2 plus 1 is 3. 3 to the third is what? 27. So it's like, this goes really, like, it really curves up, correct? Okay, so that's this one. So what's happening here? Remember, we're going to move the y-intercept. It's not going to be the y-intercept anymore, but we're going to move it. So what are we doing to 0, 1? What is that plus 1, an h or a k? It's an h because it's in the exponent. So it's going to move it to the left. How much? 1. So minus 1. So our new anchor point is negative 1, 1. So that little crook, I always call it a little crook, is going to be what?
On the bottom one. This side.
I'm on the left. Yes.
Okay.
Okay. So I might want my y-intercept, huh? To know where it's at. So what is every y-intercept? How do I find any y-intercept?
Make all x equal.
Make all x's 0. So I have 3 to the first, which is 3. So 0, 3. So 1, 2, 3. So this graph goes, it still goes towards 0 there, but it has my turning point sooner, correct? Okay. What happens on the next one? Is that an H or a K?
That's okay.
That's a K.
So it goes
So 0, 1 goes to what?
up to
Not up,
down.
down. Remember, K is the same direction. So it goes to 0, negative 1.
Yeah.
So 0, negative 1. So it goes here. Well, in this case, it might be nice to know what the x-intercept is, right? How do I find any x-intercept? I make the what 0?
Why?
The y. So if I do the x-intercept, it'd be 0 equals 3 to the x minus 2. So 2 equals 3 to the x. Do they have the same bases? No. So that's not going to be easy for us to solve right now. And even when we can solve it later on in the week, it's not going to be a number that we can do without a calculator. So we're going to just kind of wing it. Could I throw in a number, though? Could I throw in 1?
Yeah.
Okay, so if I threw in 1 for x, I get 3 minus 2, which is 1. So it goes through 1, 1. So I don't know the x-intercept, but do I have another point to go through? Okay. And now the horizontal asymptote was at x equals 0. I'm sorry, y equals 0 because it's a horizontal line, yes. But we moved everything down how much?
By 2.
By 2. So what is my new horizontal asymptote? It was y equals 0. Now it is what?
Y equals negative 2.
Y equals negative 2. So should I draw that on there also? Yes. And now does that give me a horizontal asymptote that I can show that I'm approaching? Other than the shape, is it much different than what we've done before? No. Now, I discussed the horizontal asymptote on the left, but not on the right. Why not on the right? Did it change? No. So if it doesn't change, you don't have to discuss it. If you want to go through and discuss it, you can, but you don't have to.
So this week is Red Ribbon Week. A few things going on during the week.